Hello everyone, this video is the continuation of the previous video where we discussed various properties of inverse trigonometric functions. In this video also we will proceed with the remaining properties of inverse trigonometric functions. So let us begin. We will recall some of the properties of trigonometric functions which we read in our previous years, like sine 2 theta, which is 2 sine theta cos theta. Cos 2 theta is basically it is cos square theta minus sine square theta, which can also be written as 2 cos square theta minus 1, because sine square theta can be written as 1 minus cos square theta, right? And this can also be written as 1 minus 2 sine square theta, right? And similarly, your tan 2 theta is 2 tan theta 1 minus tan square theta. Alright. Now, sin 2 theta and cos 2 theta can also be represented in the form of tan theta. You remember that, I guess, which is 2 tan theta upon 1 plus tan square theta. Right, and cos 2 theta is 1 minus tan square theta 1 plus tan square theta. All these properties you have read in 11th class, so we will just quickly recall them without proving them. Tan 2 theta you already know. Now comes your sin 3 theta. Sin 3 theta can be represented as or written as 3 sin theta minus 4 sine cube theta. Alright, and similarly your cos 3 theta is written as 4 cos cube theta minus 3 cos theta. Alright, so we are going to use these properties of trigonometric functions in order to derive the various properties of inverse trigonometric functions. So once again you can simply recall them. Now these are a few more properties that will be required, like tan A plus tan B, which is your tan A plus tan B upon 1 minus tan A tan B. I hope you all remember this vividly. And here similarly your tan A minus B can be written as tan A minus tan B upon 1 plus tan A tan B. Right? Now we will use these all these properties in order to derive our inverse trigonometric functions results and properties. Alright. Now just look at this. Tan inverse x plus tan inverse y. Now this can be written as tan inverse x whole, x plus y upon 1 minus xy. Alright, where your xy is always smaller than 1, right? So this property is very easy to prove. What you have to do, simply take, you have tan inverse x and tan inverse y. Take tan inverse x as theta and tan inverse y as phi. Alright, so x can be written as tan theta and y can be written as tan phi. Right? Now you want x plus y upon 1 minus xy. So here x plus y upon 1 minus xy is tan theta plus tan phi whole upon 1 minus tan theta tan phi. Now this is the formula of what? This is the formula of tan theta plus phi, right? So what did you get? It's tan theta plus phi is equal to your x plus y upon 1 minus xy. So simply you can say that theta plus phi is equal to tan inverse x plus y upon 1 minus xy, right? and your theta and phi are what? Tan inverse x and tan inverse y. So you got tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Alright, similarly, if you are given again the same property with minus sign, right, similarly if you are given something like this, tan inverse x minus tan inverse y, in that case it becomes tan inverse x minus y upon 1 plus xy, and you will use the same procedure in order to prove this. And then similarly you can prove tan inverse 2 times tan inverse is equal to tan inverse 2x upon 1 minus x square, where your mod of x is smaller than 1. You will again use the same thing, right? Here you will use the formula of tan 2 theta, right? Take tan inverse x as theta, go on solving, you will get the same thing. The last property that we discussed was 2 times tan inverse x is equal to what? Tan inverse 2x upon 1 minus x square, right? Here your mod of x is smaller than 1. Now this 2 times tan inverse x can be represented in the form of sine inverse also, which is sine inverse 2x upon 1 plus x square, right? Because sine 2 theta can be written as 2 sine theta upon 1 plus, now 2 tan theta upon 1 plus tan square theta. So basically what you have to do here is take x as tan theta and solve this. Here your limit is going to be, means x is going to belong to, x is smaller than equal to 1. Alright. Now tan 2 inverse can be written in the form of cos also, which is cos inverse 1 minus x square upon 1 plus x square. Alright. Here also we have derived it from the trigonometric property only. You see, if you take x as tan theta, you will get 1 minus tan square theta. See, take x as tan theta. What you will get? It's cos inverse 1 minus tan square theta, right? 1 plus tan square theta, which is cos 2 theta, means cos inverse cos 2 theta, which is equal to 2 theta only, right? Which means 2 times theta is your tan inverse x, right? So 2 times theta means 2 times tan inverse x. You got the same thing? So this only you have to use in this part. Everywhere you have to use the same thing, and you can derive all of these properties. You don't have to mug them up, you don't have to cram them. Just read it nicely, read it properly, read it thoroughly. Understand what is being applied, and you can easily, you will never require to mug it up. You can easily derive it on the spot also. Now look at these questions. Sine inverse something. Now here your motto is to convert this entity into something like sine theta. Maybe sine 2 theta, maybe sine 3 theta also. Right? But you have to bring it into something like sine theta only. Getting my point? Now you can easily see that this is 2x into something. Now you know that sine 2 theta is 2 sine theta cos theta, right? So if you take x as sine theta, take x as sine theta, you will get sine 2 sine theta, and 1 minus x square, 1 minus sine square is cos square, under root of cos square is cos. So it becomes 2 sine theta cos theta, which is sine 2 theta. So basically you will get sine inverse sine 2 theta, and then you can write it like 2 theta, which is 2 times sine inverse x, right? From this you will get your answer. And similarly you see this thing, cot inverse something. Now your motto is to bring this entity into something like cot theta, right? Now you see x square minus 1. You know 1 plus tan square theta is equal to sec square theta, right? From here you can get sec square theta minus 1 is your tan square theta. You got it? Take x as sec square theta. No, x is sec theta. Now you will get under root tan square theta, which is 1 upon tan theta only. 1 upon tan theta is cot theta. So you got it, cot inverse cot theta, which is your theta, right? Theta is equal to sec inverse x. Got your answer. Similarly, look at this one. Cos inverse 4x square minus 3x. What I told you, all you have to do is to bring this entity into something like cot theta, cot 2 theta, maybe cot 3 theta. So here, if you look closely, this is totally the formula of cos 3 theta. Cos 3 theta is what? 4 cos square theta minus 3 cos theta, right? Totally resembling this. Now take x as cos theta. If you take x as cos theta, you will simply get cos inverse cos 3 theta, which means 3 theta. And if you put replace theta, you will get 3 cos inverse x. Got your answer? Tan inverse cos x minus sin x upon cos x plus sin x. Right, look at it carefully. Now x is your smaller than pi. Now see, first of all, whenever it is given like cos x plus sin x or 1 plus cos x or anything like this, what you have to do is divide numerator and denominator by cos x. It's the simplest way and it's the most efficient way. This thing will be used in your this integral calculus also. So this is a crucial step. Divide numerator and denominator by cos x. You will get 1 minus tan x upon 1 plus tan x. Right? What have you done? You have divided numerator and denominator by cos x. This gives out tan inverse tan pi by 4 minus tan x upon 1 plus c. It is 1 into tan x, right? So you can write it as tan pi by 4 into tan x. Now you look at this carefully. What it is giving you? Tan a minus tan b upon 1 plus tan a tan b. So this is the formula of tan a plus b, a minus b, right? So you got it. Now what is your answer? Pi by 4 minus x. So this is your required answer. See what you did here. 1 was here, you were given 1, so you converted 1 into tan pi by 4. So this thing is going to be used in a lot of questions. Anywhere where you see something like cos x plus sin x or 1 plus cos x, anything like this, you quickly have to hit this, that you have to divide the numerator and denominator by cos x, which will convert it into something like this, and then whenever it is something like 1 minus tan theta, 1 plus tan theta, you convert 1 as tan pi by 4. These are some hacks which will help you in solving the questions. Alright, so this is your required answer. Okay, now look at this question. It's sine inverse 1 by 5 plus cos inverse x is equal to 1. Now they have asked you to find the x. Find your x, right? So you see here, it's sine inverse plus cos inverse. So are you getting any idea? See, all you know from the properties is that sine inverse x plus cos inverse x is your pi by 2, right? This is a property you have read. Now let us try to use this property, because only this property is resembling this. So you are going to use this property only. So first thing that I will do is take sine that side, plus cos inverse x is equal to sine inverse 1, right? So this can be written as, sine inverse 1 can be written as 4, 1 by 5 plus cos inverse x is equal to sin inverse 1 is pi by 2. 1 is sin pi by 2. Sin inverse sin cancel, beta pi by 2. Now you know sin inverse, use this property now, right? You got sin inverse 1 by 5 plus cos inverse something is pi by 2. So x has to be what? X has to be 1 by 5 only. Compare this and you will get your answer. Got it? Now see, I guess these many questions are sufficient for you to use to apply your mind now. So go on solving a lot of questions. Use good books like go for R.D. Sharma, go for maybe Ashton would work. First of all, first hand NCERT is a must, and then go for other books and solve as many questions as you can. But and one thing, please keep one thing in mind: you must not check the go for the solution. All right, that's all.